I'm going to be going over activity 4.7 with you guys, talking about the different types of bonds that we see and then also their physical properties. So the first is a covalent network. And so here you see the image. You can see that it is very well structured. And all of these atoms are held together through covalent bonds. So they create this grid-like structure. That's why it's called a network. So some examples of these are like diamonds, graphite, both of which are made of carbon, or silica, which is a key component in making glass. So they are held together by covalent bonds, and because all of these atoms are held together by the covalent bonds, it creates this hard crystal structure. So the actual structure that you see here is what helps to provide that stability of the crystal. Okay, so that's why, diamonds are one of the strongest materials that we have here on Earth. It's due to this covalent network of the atoms being bonded together. Okay, it does not usually conduct electricity, though graphite can. And then it will not dissolve in water, and it actually has a very high melting temperature. Okay, and so a key reason why it has a high melting temperature is due to the structure. So because these bonds are very sturdy, it holds together the substance longer, keeping it in that solid state longer. The next is covalent molecular, and so examples of these are like sugar, water, and carbon dioxide. So I'm going to kind of focus mainly on water. In this image, each of these molecules are water molecules, and if you remember, water is a polar covalently bonded molecule. Okay, so we have oxygen and hydrogen, and they are bound together covalently. Okay, but what is unique about these covalent molecular structures is that the individual molecules, are actually held together by these weak forces. Okay, so you can see these dotted lines between the different molecules. It's showing that there is a weak bond happening between these, and it actually helps to hold them together. Okay, so in this case, it's a hydrogen bond. It could be a dipole, and so if you remember, because water is polar, meaning it has a positive end and a negative end, they're attracted to each other slightly. Okay, and so because this is hydrogen, they do call it a hydrogen bond. It is not a real bond. It's just these weak forces that are holding them kind of together. Okay, and so because these molecules are held together by weak forces, generally the structure is going to be very soft and flexible, but it also can be a brittle crystal like sugar. They do not conduct electricity, and you might be a little confused by that because if you've ever been out when there's like a thunderstorm where there's electricity involved, they say stay away from water or like get out of the pool, and so you might be led to think that water conducts electricity. It does not. Pure water does not. It's the chemical or the compounds that are dissolved in the water that conduct electricity. Okay, so if we had a pure water sample, it would not conduct electricity. Okay, so covalent molecular do not conduct electricity. Polar covalent compounds will dissolve in water, while the non-polar covalent compounds will not. So generally, with dissolving, it's going to break down into ions. And so if it is a polar compound, the water is able to kind of go in and break down those compounds into its different ions. Otherwise, it will not be able to, and so it won't dissolve. And then it also has a low melting point, and this is just due to the weaker bonds holding together these molecules. The last is ionic, and examples of these are generally salts. Most ionic bonds are salts. So like NaCl, which is table salt, or calcium chloride. And so these are held together by ionic bonds because it is a bonding of a metal and nonmetal. And so the structure of this is going to be a brittle crystal structure. So if you look over here at the diagram, you can see it's similar as far as it has quite a bit of structure compared to what we saw with the covalent network. Okay. One key distinction, though, is that the shape of the network or the bonds are different. So you'll see that this one has a hexagon shape, okay, which actually gives it more stability than this, which just has a cube shape or square shape to the bonding of the different atoms. Okay, and so because of this, it's not as strong, so we're going to generally see that it's more of a brittle crystal solid than that very strong structure that we see with the network, the covalent network. When ionic compounds are dissolved in water, the solution can conduct electricity. So whenever you think about water being conductive of electricity, it must mean that there's some kind of ions in there. And generally, if we have like salt, so if we had water, we had pure water in here, tested the electric or the ability to conduct electricity, it would not. But if we were to put salt in there, table salt, and dissolve it, we should find that the sample then would conduct electricity. Okay, so it is the ions found in water that causes the electricity to be conducted. Okay, most of them will dissolve in water. Okay, because they're ions that are produced here, the water is able to break them up, and then the melting point is going to be fairly high because it does have this nice structure to it. It doesn't have the weaker bonds, so it does have high melting temperature.